Send a post for everyone. Okay, done with that. Here we go. Okay, so I'm just going to do number 3. So make sure you have that one somewhere on your paper. If you've already done this problem, just follow along and make sure you followed all those same steps. Okay, so the problem was 6 negative 3x plus 1 equals 5 times negative 2x minus 2. Okay, so we kind of talked about this a little bit already on the very first day that we started reviewing. Okay, we talked about that when we had a problem where there was nothing that we could simplify inside of our parentheses and we had a number on the outside of our parentheses, what do we do? Who remembers what that's called? Right, the distributive property. So I would make a little step 1 somewhere on your paper. I don't have any room off to the sides. Step 1, distributive property. Spell it the best you can, it doesn't matter. Okay, because we'll utilize that property a lot as we move forward. So we know that when there's a number on the outside of a parentheses, what operation are we doing? Multiplication. So we're going to take that 6 and we're going to multiply it by everything inside of the parentheses. Okay, so let's simplify that. So we have 6 times a negative 3. What's 6 times negative 3? Negative 18x. Don't forget to bring down your variables. Then we have 6 times a positive 1. 6. Okay, is it a positive 6 or a negative 6? Positive 6. So we have to make sure we put that plus sign in there. Okay, all of that equals, we have 5 times a negative 2x. What will that be? Negative 10x. All right, and then again, this is the part I need everyone to look up here and pay attention to, because if you move on and do number 4 without really paying attention to this, you may miss it. This is 5, positive 5 times a negative 2. Okay, even though that is a subtraction sign, it's making this a negative 2. So what is 5 times a negative 2? Negative 10. Okay, so always pay attention to those operations that are in front of it, because that's going to tell you whether it's positive or negative. Okay, so now this looks like number 1 and the other one that we worked together. Okay, so after we did the distributive property, we're still solving equations. So our goal is still to solve for x. But I have to do something first before I can do that. Who remembers what that's called? We wrote it on the notes on number 2, just like this. Starts with a C. Combine like terms. Okay, so off to the side. Step 2, we're going to combine like terms. Okay, so the reason that it's important to do these little notes is because it's only been like less than a week since we've done this together, and some of you all have already forgotten. And I'm not saying that to make you feel bad. I'm saying that think about if we come back to this in 3 months. Okay, you're going to want those little notes to remember how you did things. Okay, and it takes half a second while I'm up here explaining something else like this. Okay, so combine like terms. So I like to combine the like terms that have variables with it. So we talked about this a little bit. I want to get all my variables on one side of the equal sign, and I want to get all my whole numbers to the other side. Okay, so how do we take and move things to each side of the equal sign? Someone said it earlier. Inverse operation. Inverse operation. So does it matter if I move my x's over here or if I move them over here? No, it doesn't. Okay, you just have to choose one way to do it and stick with it. So I'll let y'all decide. Do we want to add the 10 over here? Do we want to move the 10 over here or move the 18 over here? Okay, let's move the 18. Okay, so Kaden said it a second ago. If we want to take a term and we want to move it to the other side, we use inverse operations. Okay, so we're taking this entire 18x. Okay, and we're going to move it over there. So it's a negative 18x. How are we going to move it to the other side? Plus 18x. Now, a lot of people said, well, Ms. Frisbee, it's negative 18 times x, so why don't we divide? And that would be what you did if you were just moving the 18, okay? But since you're moving the whole term, you are adding and subtracting it, okay? Because that term is being added and subtracted to the other part of the equation. Okay, so if I do it to one side, I have to do it to the other side. So what happens to my 18s? Cancel out, and I bring down my 6. Okay, now we have to simplify negative 10 plus 18. Okay, 8x. Now, if you can't do that in your head really quickly, you could easily go to your calculator. Take an extra second. Negative 10 plus 18. You don't have to put the x's in the calculator. Okay, so we get positive x. There. Okay, so there we get our positive 8. Okay, bring down my x, and then I need to bring down my negative, or my minus 10. Okay, now this looks like every other equation you've worked before. We're trying to solve for x. So if we're trying to solve for a variable, we start with a term that's furthest away. So how do I move this minus 10 to the other side? If I do it to one side, what happens to my 10s? Okay, I bring down my 8x. Simplify the other side, 6 plus 10. All right, almost finished. Am I finished yet? How do I know? Okay, we have something still with our x. So that's 8 times x. So what do I have to do? Divide by 8. What happens to my 8s? Okay, and then 16 divided by 8, 2 equals x. Or x equals 2, whichever way you wrote it. All right, so you can see how every single thing we've learned, distributive property, combining like terms, solving equations, that was all used in one problem, okay? So everything in math you're gonna learn, it just all builds off of one another, okay? So if you don't understand it, now's the time to ask me questions. Now's the time to do extra practice, because honestly, the more you practice it, the easier it gets, okay? You see how repetitive the steps become. So yeah, the questions I had you doing in your groups were numbers 2, 3, 4, and 5. We just did 3, so you're done with that one. I'm going to give you a few minutes to finish the 2, 4, and 5 in your groups. And then we're going to come back together and I'm going to check them. I'm actually going to go ahead and put the answers up here. So if you've already done them, you can check your work. Now, if you and your group are doing number 2 and you get the wrong answer, before you ask me what you did wrong, go back and see if you made a little mistake in your work first, okay? So if you're trying to find these on your Google Classroom to find the questions, go back to Google Classroom, go down to 3B. Y'all don't have to do all this. So because this is what we did last week, it's still going to be under the August 31st through September 4th tab. I'm going to try to do all of the materials I go through in a week under each weekly tab, so it kind of stays organized. It's going to be under the solving equations, and it's the second one. Variables on both sides, okay? So I'm going to put the answers down. So number 2 is k equals 4. Number 3 is, we just did that one, x equals 2. Number 4 is y equals 13. And number 5 is y equals, or x equals 9. You can't see that. Okay, you can move and work with a partner on these. That's going to be up there for you to check your answers. I'll give the Zoom kids a second to write those answers down before y'all work on them, because I'm going to put you on a breakout session so y'all can talk. And it won't be, anyone out here can't hear it. Okay? All right, I'm going to give y'all about, let's start 7 minutes, because most of y'all are probably close to being finished with all these. Okay? 7 minutes, here we go. Timer start, you can move. Make sure if you're working in a group, you have your mask on. Two, 3, 4, and 5. 2 through 5. Same ones. So if you've already done this. Y'all doing good? Zoom people, y'all doing good? Okay, if y'all have any questions, just let me know. Okay, I'm not going to spend a ton of time going over these again, because we did only add just a couple more steps to what we were mostly doing last week. So between these 4 that we were going to do, hopefully you got most of them done last week. Which one do you really need me to work through? I'll do one of, maybe 1, maybe 2 at the most. Riley, number 5. Okay. Rebecca, 5. Okay, awesome. Well, that's easy. Okay, so we'll do number 5. So let me get another sheet of paper out. Okay. So even if you work this one and got it correct, please pay attention while we do this. It's not going to hurt you to watch through it again. Okay? So the question is 2/3 x minus 6 equals 6 minus 2/3 x. Okay, when I'm doing this one, do I need to do the distributed property first? No. How do we know? There's no parentheses, so we don't even have to worry about that this time. Okay, so if I don't have to do distributive property, what's my first step to do? Combine like terms. So I like to combine my variables first. So I have 2/3 x and I have negative 2/3 x. Okay, so I need to get those variables and move them to the same side of my equation. Okay, I'm just, instead of asking all this one, I'm just going to tell y'all what I think is the easier way. I think I mentioned that I like to keep it to where hopefully they'll end up being positive. So I see that I have a subtraction, so I'm just going to add it to the other side, okay? Because I prefer for my stuff to stay positive. So if I have a minus 2/3 x, how am I going to get it over here? I'm going to add 2/3 x. If I do it to one side, Gotta do it to the other side. What happens to my positive and negative 2/3 over here? They cancel out. So I have a positive 2/3 plus 2/3. Okay, we learned a really handy trick in our calculators. Okay, so I could do 2 divided by 3 plus 2 divided by 3. All right, I'm not going to keep it as this decimal. I want to be able to write it the most exact way I can, so I'm going to convert it to a fraction. And it's going to be 4/3. Okay? So that should take the fear out of fractions. Okay? So that would be 4/3 x. Bring down my -6 equals +6. Right? Okay, so just like solving equations, I'm trying to get this x by itself. This is just a regular equation. So if I'm trying to get x by itself, I start with my term that's farthest away. So how do I get rid of that -6? I add 6. If I do it to one side, do it to the other side. What happens to my 6's over here? Cancel out. What's left over here? 4/3 x equals 12. Okay, now this part kind of confuses people, but it's the same thing. That's 4/3 times x. How am I going to get rid of my 4/3? Divided by 4/3. If I do it to one side, I do it to the other side. My 4/3 will cancel out. And I don't know what 12 divided by 4/3 is, but my calculator does. So I have 12 divided by parentheses 4 divided by 3. And it comes out to a nice, beautiful whole number of 9. All right. So don't be intimidated by the fractions, okay? If you follow the same steps you're supposed to every time and use your calculator, nothing changes. Okay, we're gonna stop there with that. We're gonna move on to the next thing. So leave your Chromebooks out. I actually have your notes printed off for you this week, just because it was a little easier. So for y'all on Zoom, if you go to this week's assignment in Google Classroom, you'll see the notes that I'm passing out. If you have a printer, you can print them off. If not, you just copy it into a sheet of paper. Okay, did I miss anybody? Okay. So what you're gonna do is the way you look at these, ignore the cut off the section part because we're actually gonna be writing on some of that. You're gonna be looking at this side, the one that doesn't have the bolded titles. You're gonna look at the other side. Okay, what you're gonna do is you're gonna take the sides and take one side and fold it to about halfway and make a little tab. And then you're gonna do the same thing with the other side. so that it creates like a little booklet. All right, and at the top of this sheet of paper, or if you're at home and you just have a sheet of paper that you're taking notes on, you're just going to write graphing equations. Graphing equations across the top. Now, the way that these notes work is that when you come back to them, there's 4 little examples on the front. So these are the 4 examples I'm going to work through with you. And then when you open it up, so like for this section right here, given the slope and the y-intercept, these 2 practice will come from that example. Okay, if you're under the slope or y-intercept is 0, then when you open it, those top 2 will go with that example. Okay, so you'll have 1 example for every practice you have. Okay, so before we get started on those notes, there's just some basics we need to get started with and review over with graphing equations. Bless you. Okay, so if we're starting at the very, very, very basic understanding of what graphing equations is and what slope is and all that kind of stuff. Okay, first of all, everyone who's done this lesson has felt like they understood it a little bit more. So don't stress if you had a stressful experience with it last year. Okay, we're going to get through it. But the very basic first thing you need to understand is slope, intercept, form. Slope, intercept, form. All right, does anyone remember what slope, intercept, form is? Y equals mx plus b. Good. Okay, so when I'm talking about slope, intercept, form, I mean that your equation has to be written like this, in this form. Y equals mx plus b. Good. So the dead giveaway that this equation is in slope, intercept form is that it's set equal to y. Okay, so anytime you have an equation that's set equal to y, that means that you can graph it. Okay, it tells you the two important things that we'll talk about here in a second that you need to know in order to graph. So I want you to hear me when I say this. Okay, if your equation is not set equal to y, you cannot graph it. So if it looks like this down here on your little paper, if it looks like this, it's not set equal to just y. It has a bunch of stuff on the same side as y. We can't graph that, okay? You have to do something to it first so that you can. And we'll talk about that here in a second. So when it's set equal to y, which means it's in slope intercept form, the equation tells us two very important pieces of information. Yeah, okay? So based off of the name of the form, what 2 pieces of information do you think it gives us? Based off of its name. Okay. The x and y slope. Okay, it tells us the slope. And what else do you think? The intercept, the y-intercept. Do those things sound familiar from last year? Slope and y-intercept. Okay, so when it's set equal to y, and you're looking at the mx plus b, the number that comes in front of your x is always going to be your slope. The number that is paired with the x will always be the slope. Okay? The number that is all by itself over here, it's usually a whole number. And I'm including the operation because that tells you whether it's a positive or negative, is always going to be the y-intercept. Okay? So if you have an equation that is set equal to y, then you know that what the slope is because it's the number next to x, and you know what the y-intercept because it's the number by itself. Okay, so a lot of the times if you're given an equation or anything like that, a student can say, okay, this is the slope, this is the y-intercept. They can tell me those things. However, they have a hard time taking that information and then graphing it because they don't know where to start. Okay, they know what those two things are, but they don't know how to put their pen down and start drawing it. Okay, so when you're starting your graph, when you're starting to draw it, always start with your y-intercept. So with your y-intercept, I call that my starting point. My starting point. That's my y-intercept. That's the only point that I know exactly where it is when I'm given my equation. That's where you have to start. Okay, so let's look at these examples. So this is example 1. Okay, this is going to be the most basic. It tells me my information straight up. Okay, so for those of y'all that are at home and you want to title your notes, title this section, given the slope and y-intercept. Okay, so it says m equals 2. When it's talking about m, what is it talking about? Slope. Okay, so my slope equals 2. Okay, and then it says b equals 1. What is b talking about? The y-intercept. Oops. And I always like to shorten it to y-int. I don't want to write it every time. Okay, so do we have the two things that we need in order to write it in slope-intercept form? Yes. Yes. So we start out with y equals. Okay, so m is 2x. And then we have a positive 1, so plus 1. All right, so it's easy writing the equation, right? Okay, so let's see if we can graph it. What's my starting point with this equation? Where do I start? Nope.
No, 1.
My 1. Why do I start with my 1? That's my y-intercept. So what does it mean to have a y-intercept?
That's where it runs through the y-axis.
That's where it crosses the y-axis, okay? So it's going to cross through my y-axis where?
At 1.
At positive 1. So I'm going to look at my y-axis, which is the vertical one, and then I'm going to go to positive 1 and graph it. Okay, not bad. First part done. Now, in order to graph the slope, we need to know what slope is. So quick refresher on slope. Going back up to the top of your page. Slope is the rise over the run. Okay? So basically it's breaking up whatever number is into a numerator and a denominator. Okay, your numerator will be, so a fraction. So if your number is not a fraction, you need to listen and pay attention to what you have to do. So your numerator is going to tell you whether you're going up or down, and your denominator is telling you whether you go from left to right. Okay, so let's look at it. Do I have a fraction as my slope? No, I have a whole number, okay? But the slope is still the rise over the run. So anytime you have a whole number, just put it 1 as your denominator, okay? Because if you were to simplify that, because we know that a fraction is just a division problem, 2 divided by 1 is still 2, so it's not going to change your slope. Okay, so let's graph the slope, going back to our starting point. Okay, we have 2 over 1. So we're going to start at our starting point. We're going to rise 2, 1, 2, and we're going to run to the right 1 and graph the point. Okay? Then we're going to go to the point we just drew, and we're going to rise 2, and we're going to run 1. And we've run out of graph. Okay? So if that happens, which it will a lot, you can go back to your starting point and go the opposite way. We can go down 2 to the left 1 and keep going until we run out of graph. Okay? And when we connect all of those little dots we just made, it forms a straight line. Okay? So when you're looking at that equation, this is what it looks like if it was graphed. Okay? And something cool is your calculator can graph these as well. Okay? Which we'll get to that later. So that is the very basic of graphing equations with this example. Are there any questions on how I did a certain part before we move on? Okay, let's look at the next one. The slope or y-intercept is 0. Okay, so we always start with y equals. Do we have a slope? No, it's 0. Okay, so we don't even have to write 0x, okay, because that's just 0. Okay, so then that means we just have y equals what? -4. So slope tells you how your graph increases or it decreases. So we can see in this last one we drew that it was increasing at a very rapid pace, right? Okay, that's what your slope tells you, whether it's going up, whether it's going down, whether it's steep, whether it's flat, all of that kind of stuff. So let's graph this one and see what the slope tells us about it. So our starting point is always our what? Y-intercept, which is the number all by itself. So what is my y-intercept for this graph? -4. So I'm going to go ahead and graph it. So the slope tells me how it's increasing or decreasing. Is this graph increasing or decreasing? No, the slope is 0. So if it doesn't have a slope, it's not increasing or decreasing. So it's just staying the same, constant. Okay, so we're going to have a straight line. It doesn't increase, it doesn't decrease, it stays the exact same. All right, this next one is going to probably be the part that is the most confusing, but I still think y'all will pick up on it pretty quickly, okay? Because it's very similar to what we just did with solving equations. Okay, so just like everything else, this all builds on top of each other. Okay, example 3. We talked about this a little earlier. I just kind of bopped down here for a second. What's wrong with this equation? I heard someone, I don't know what you said. Say it one more time. There's not an M. Okay, so this time they've already filled in the numbers for us in the equation. Okay, but what else? I said something earlier. If it's not something, you can't graph it. Kaden? Not necessarily. You're getting warmer. Okay, not necessarily. Look at how the equation is set up. Yeah, we do have to do a step first, but what are we trying to do? Our equation always has to be set equal to y. Okay? It has to be y equals the rest of your equation. Is my equation like that? No. So what you're going to have to do, which I don't have a lot of room down here, we have to solve for y. We have to solve the equation for y. Okay, I wrote it below my graph because we're about to use this tiny little area above the graph. Okay, so this is just like solving equations, only this time we have two different variables, okay? All the same procedure, okay? Nothing changes. Okay, we're solving it for y. So if I'm solving an equation, I need everyone looking up here because you're going to have to do this on your own in a second. Okay? If we're solving for y, we start with the term that's furthest away. So I want to move all of this to the other side of the equal sign. So how do I get rid of a positive 2x? Minus 2x. If I do it to one side, I have to do it to the other side. All right, now this part I want you to pay close attention to. Well, not this one. What happens to my 2's? Cancel out, bring down my y equals, okay, off to a good start. Now, can I combine these two terms? Can I make that 1x? Why can I not combine these? Because 3 doesn't have an x, they're unlike terms, okay? So all I'm going to do is just rewrite them like a normal problem, okay? Just like in that slope-intercept form. So I'm going to bring down my negative 2x and then my plus 3. Okay, so now it's in that slope-intercept form. Do y'all see that? So now looking at that, do I know my slope? Do I know my y-intercept? Can I graph? Okay, so looking at this equation, someone raise your hand and tell me what my slope is. What is my slope, Braden? Negative 2. Can someone else tell me how Braden knew that that was my slope? Caden, how did he know that was my slope?
Because there was X at the end.
Yep. So the number in front of your x, the number that's paired with your x, is always your slope. Okay? So now looking at that equation, which one is my y-intercept? Macy? Positive 3 is my y-intercept. Okay? And you don't have to label these every single time you're graphing it. I'm just doing that so it can be embedded in your brain. Okay, so now let's graph. Where do I start when I'm graphing? Raise your hand. Jocelyn? The y-intercept. So I'm going to start at positive 3. I'm going to look at my y-axis and I'm going to go up 1, 2, 3. That says slope right here. I'm looking at it now. It's kind of hard to see what that says. It says slope up there. Okay. So I've got my y-intercept. Now I'm done with the y-intercept. I don't need that 3 anymore. Okay. So now my slope is negative 2. If my slope talks about how my graph increases or decreases, and my slope is negative, what is my graph going to be doing? It's going to be going down. It's decreasing. Okay. So we talked earlier about how it's the rise and the run. Okay. Do I have a numerator and a denominator? So it's understood to be over 1. So that's negative 2 over 1, which I can't really write it without it looking sloppy. I'll do it anyways. Oh, you can't see it. Kind of. Okay. So I'm going to start at my starting point. And am I going to go up 2 or down 2? Down 2. And then here's the part where a lot of people get confused. I go to the right. Still 1. Okay, a lot of people want to go to the left, but if I went to the left, I'm going to use orange this time. And I were to connect those 2 dots, what's my graph doing? It's increasing, okay? But if I have a negative slope, that means it's decreasing. Let me X this little guy out. Okay, so then I can start at the point that I just graphed, and I can go down 2 over 1, and I can just keep going until I run out of graph. Okay, get your rulers, connect your dots. Okay, same process, you just have to do that extra step at the beginning. And I can't emphasize enough how often you're going to have to solve an equation for a different variable or do something like what we just did. Okay, so make sure you really practice that. Okay, one more. I'm gonna let you work in your groups again. Y'all are doing awesome. Stay with me. One more. Now we're gonna do the slope. We're gonna write the equation when we're just given the graph. Okay? So in order to write an equation, we need two really important things. What are those important things? Slope, y-intercept. Okay? So let's find those two things. Go off to the side, I wrote slope, y-intercept. Because for some reason, those are the letters they chose to mean those things. Okay. So just looking at this graph, one of those two things is really easy to find. What is it, Jocelyn? The 2, that my y-intercept. Okay, I can see that that's where my line is crossing through. So my y-intercept is a positive 2. All right, and this next part, I don't really know how else to explain it because it's not super mathematical. But what I do is I look at my line and I try to see all the different points that are crossing straight through a coordinate. So like if I'm looking here and I go to the right, I can see that that's not really going through any specific point. Do y'all see that? So then I'm going to go to the next one. Okay, that one looks like it's crossing right through that. So I'm going to add a little dot. Okay, and I'm going to keep doing that for every single spot that I see that it looks like it's crossing through. Okay. Then I'm going to start at my starting point, and I'm just going to see how I got from my starting point to that next dot. Okay, so I went up 1 and over 2. I went up 1 over 2. Okay, if I went the opposite way, I went down 1 over 2. Okay, so what would my slope be? 1 over 2, or 1/2. Okay, is it positive or negative? Positive. How would I know that my slope was going to be positive just by looking at it? The line is increasing. Okay, so do I have everything I need to write my equation? Yes, I do. Okay, I do y equals m, which is 1/2, x plus b, which is positive 2. All right. I'm going to give y'all, let's say, what time is this class over? 1:30? I'm going to give y'all 15 minutes because y'all are way ahead of my other classes. Okay? I'm going to give y'all 15 minutes to work with a partner to work through these problems. Please try to get all of them finished. And I highly recommend using a pencil. Okay? Because what's going to be really annoying is if you do it in a pen and you ask me if you did it correct and you didn't. So for these, try to do, if you don't have a pencil, I have pencils in the back. Okay? As soon as I get everyone in their rooms. Okay. So when I have this, it tells me my slope is 1/2 and my y-intercept is -3. So I'm going to start at -3. That's my starting point. I'm going to go up 1 over 2. Up 1 over 2. Okay? We all good on that? Next, my starting point was +2. And my slope is -3. So immediately I should know that when I'm finished drawing this, my line should be decreasing. If it's not, I've done something wrong. So starting at my starting point, I go down 3 over 4. Okay, well, I've already ran out of graph. So I'm going to go back and I'm going to go up 3 to the left 4. Okay, next one. I know I'm going quick, but this is being recorded and y'all can always go back and rewatch parts if you're confused. Okay, so this one, y equals -2x. My y-intercept is 0. You don't necessarily have to add the 0, but it is where you're starting. Okay, that is still my y-intercept. So I'm starting at 0 at the origin. Okay, and then my slope, if I have a whole number, it's understood to be over what? 1. So that means I'm going to go, it's -2, so am I going to go up or down 2? Down 2 to the right 1. Down 2 to the right 1. And I'm going to continue that. Okay, give me a thumbs up when you're ready for me to move on. My Zoom people still here. All right, we good? Okay, next one. This time it was y equals 0x plus 3. We don't have to write the 0x, that's just 0. So we just have y equals +3. So I'm going to go to +3 on my graph. If it doesn't have a slope, that means it's not increasing or decreasing, so it's just constant. All right, here's the ones where we might have got a little confused on. Okay, but that's okay. We're going to learn. We're going to know how to do it. So I had 2x plus 3y equals 6. I'm solving for y. So I have to subtract 2x, both sides. So I'm left with 3y equals, can I combine these two terms? If you got 4x right here, it's because you combine those terms. So I'm just going to bring down, I like to bring my x down first so it's still in slope-intercept form. So I have -2x plus 6. I kept the same signs that I had up here. All right, now I'm trying to get rid of this times 3. So I divided by 3. If I do it to one side, I have to do it to the other. So I'm dividing -2 and 6 by 3. -2 divided by 3 is just -2/3. It won't simplify, and you don't want a decimal. And then I have 6 divided by 3 is what? +2. Okay? So there's my equation. Do I know my slope? -2/3. Do I know my y-intercept? +2. Okay, so I go to +2, my starting point. I'm going to go down 2 over 3. Graph my line. Okay, next one was 5x plus 4y equals 8. Can I graph it in this format? No, what do I have to do? I have to, kind of, I have to, did you say simplify or solve for y? Oh, we will eventually have to simplify, but we have to do that by solving for y. Okay, so I'll start with the term that's farthest away. So I have a +5x. How do I move it over here? -5x. If I do it to one side, got to do it to the other side. What happens to my 5x's? What's left? 4y equals, can I combine these? It's not 3x? No, it's -5x plus 8. Or you could have had 8 minus 5x. That is also true, but I like to keep it in slope-intercept form. Okay? Now I have 4 times y. How do I get rid of that 4? Divided by 4. Do I just divide the 8 by 4? No, I have to divide the entire thing by 4. Okay, so what happens to the 4's over here? Cancel out. I'm left with y equals, okay, -5 divided by 4. You can just ignore the x for a second. -5 divided by 4. If I looked at that, I would have no idea what that is. But luckily, you all have calculators. So I have -5 divided by 4. And that gives me what? 1.25. Do I want to leave it as a decimal? No. I go to math, enter, enter, and I get -5/4. Okay, so I'm going to just bring that down, -5/4, bring down my x. And then I have 8 divided by 4. Okay, if I don't want to do that in my head, 8 divided by 4 is 2. So I'm left with a +2. Do I have everything I need to graph? Okay, my slope is what? -5/4, and my y-intercept is what? 2. Okay, so if I go back to my graph, +2, I'm going to go down 5/4. Once again, it's a negative slope, so it's decreasing. Okay, last 3, you need to find the slope and the y-intercept in order to write the equation. All right, so I go through and I try to find all the points that it's already crossing through. What's my y-intercept? +1. Okay, and if I start at my y-intercept and I go to the very next point, I'm going up 1/2. Okay, so what's my slope? 1/2. Would I leave it like this? No, I need to write it as an equation. So y equals 1/2 x plus 1. All right, next. I'm going to go through and I'm going to find all the points that it's crossing through. What's my y-intercept? -1. All right, and if I'm going from my starting point, I'm going down 1 to the right 1, down 1 to the right. Okay, the whole time. So what's my slope? -1, and you can just leave it like that. Would I leave it like this? Nope, got to write it as an equation. Y equals -1 x minus 1. All right, last one. Excuse you. All right, we have our points. I'm going to look and see where all they intersect. That looks about right. Okay, what is my y-intercept? What? -3. Okay, and from my starting point to the next point, I go down 1/2. So what's my slope? -1/2 or -1/2. So my equation will be -1/2 x minus 3. Y equals all that. Okay, so that's the last thing we're doing as far as reviewing. The next time you are in my classroom, we're going to spend the majority of the time just practicing these skills. It'll almost be like a review day for all the stuff we've learned. And then we will have a quiz on it the next time, okay? If you want more practice, you can come to me and get it. But you do have homework over this one. So y'all pay attention real quick so I can show you where that's at. Go to Google Classroom. I feel like I have so many of these open. You're going to use the rest of your class time to get started on this. This homework is due tomorrow. It will be for a grade, so you need to listen to what I'm saying. Okay, you'll go to classwork. You'll go to this week, September 8th through the 11th, and it's right there under homework. Once I get time to do it, here's the Zoom for this lesson will be attached to this because it has the notes and it has extra practice in there. y'all hear that? Extra practice for slope is right here in the today's dates, notes, and practice. The homework is due tomorrow at 11 p.m. So you have until tomorrow night to get it finished. Now listen to what I'm saying, because this is how it's going to work all year. Okay. In the assignment, I wrote, show all your work on a separate sheet of paper. So if at any point you want to redo the assignment, I've opened it to where you can attempt it 3 times. But after you do it once and you don't like your score, it's just going to restart the exact same quiz. Okay? So in order to keep you from having to do all the questions again and you not knowing which one you missed, show all of your work on a sheet of paper. Bring me that sheet of paper if you want to do it again, and I will check mark the ones that you need to look at. Okay? Because when you take it again, it's going to be all the same questions. Okay. Bye, Remy. Okay? So make sure you do that. If you come to me saying you want to redo it, but you don't show me any work, then I won't know which ones you missed. Does that make sense? Okay? So go ahead and get in the habit of writing them out on a sheet of paper so that I can tell you what you're missing or where you're going wrong. Okay? Because I know how frustrating that is, especially on Khan Academy, when you do the same problem 10 times and you miss it every time, you don't know why. Okay? That way I can see where you're messing up, correct it, and then let you do it again for a better grade. Okay? Now, the redos don't have to be done by tomorrow. You have to attempt it once for tomorrow, but you still have to show all your work if you want to do the redo. So we all understand? Okay, you can go ahead and get started. I'm going to give you all about 5 more minutes, and then it's going to be time to go. All right, Zoom people, do we all understand how the homework and stuff works? Okay, try to get that done by tomorrow, and that is it. Bye, guys.